Hello, how are you? I hope you're feeling good. Today, I'll talk in my presentation about Lesson 1, Unit 1. I hope you will like it. And if you have any questions, please don't be shy. I'll answer your question privately with all pleasure. This is Ms. Isra Saad from Science Team at New Generation Language School. So, by the end of this video, students will be able to determine the concept of mass, determine the concept of density, and finally calculate the density. So, first, this is the lesson 1, matter and its characteristics. Matter and its characteristics. Do you know that, my friend, everything around us on the Earth's surface is called matter? And any matter has mass and volume. So, we will start with the definition of matter. So, matter, it's anything that has mass and volume. It's anything that has mass and volume. So, what is the meaning of mass and what is the meaning of volume? First, mass. It is the amount of matter that the object contains or that the body contains. And the measuring unit of mass is gram or kilogram. Second, volume. It is the space that is occupied by the body. And the measuring unit of volume is cubic centimeter or cubic meter or liter. And now we are gonna talk about the properties of matter. So, do you know that, my friend, matter can be distinguished from each other by physical properties and chemical properties? We will start with physical properties. Physical properties of matter are: number 1, the color, taste, and smell. Number 2, density. Number 3, melting point. Number 4, boiling point. Number 5, hardness. Number 6, electric conduction. Number 7, thermal conduction. And what about the chemical properties? Chemical properties: metals and the chemical activities are divided into 3 categories. Number 1, very active metals. Number 2, less active metals. And finally, inactive metals. So, dear friends, we will start with the color, taste, and smell. It is the property that can sometimes be used to differentiate among different materials, such as number 1, color. We can differentiate between iron and silver, silver, and gold by the color. As you see in this picture, there is a difference between the color of them. Number 2, taste. We can differentiate between sugar, table salt, and flour by the taste because all of them had the same color. And finally, smell. We can differentiate between vinegar and perfume by smell. Yeah, for sure. So, dear friends, don't taste or smell any substance in the lab without asking your teacher first. Why or good reason? Because some substances may harm you. Don't forget that. And some substances have no color, no taste, no smell, such as water and oxygen gas, but they differ from each other in the other properties, such as density. Density. Density, it is a mass of unit volume of substance, or it is a mass of 1 cubic centimeter of a substance. Again, it is a mass of unit volume of substance, or it is the mass of 1 cubic centimeter of a substance. And the law of density equal mass over volume, and the unit or the measuring unit of density is gram per cubic centimeter. What is meant by the density of water is 1 gram per cubic centimeter. This means that the mass of 1 cubic centimeter of water equals 1 gram. Okay, notes. Number one, the density of matter is a fixed value. How come? The density of matter is a fixed value whatever the used values or masses differs. For example, the density of a cube of copper whose volume 2 cubic centimeter is the same density of another cube of copper whose volume is 10 cubic centimeters. So the density of matter is a fixed value whatever the used values or masses differ. What happens when decreasing the value of a body to half? For sure, the density remains constant. Okay, number two, each substance has its own density. There aren't two substances that have the same density. Therefore, equal volumes of different substances have different masses. And equal masses of different substances have different volumes, both of them due to the difference in density. Okay. For example, the mass of an iron equal 78 gram and the volume of the liquid equal 100 cubic centimeter. So the value of the liquid and iron equal 110 cubic centimeter. Calculate the density of iron. First, the volume of iron equal 110 minus 100 equal 10 cubic centimeter. So the mass equal is the density equal mass over volume. So it's 78 over 10 equals 7.8 gram per cubic centimeter. I think it's so easy. Another question. In an experiment for determining the density of a liquid, the following results are recorded. Number one, the mass of an empty cylinder equals 75 gram, and the mass of the cylinder containing liquid equal 135 gram. The volume of the liquid equal 100 cubic centimeter. So calculate the density of liquids. First, the mass of liquid equal the mass of the cylinder containing liquid minus the mass of empty cylinder, because we want the mass of liquid without the cylinder. So it's 135 minus 75 equal 6 gram. And what about the density? Density of liquid equal mass of liquid over volume of liquid equal 60 over 100 equal 0.6 gram per cubic centimeter. Another example, on determining iron density using a piece of iron whose mass is 176 gram. The iron piece is immersed in 60 cubic centimeter of water. The water is up to 80 cubic centimeter. Find the density of iron. So, what about the solution? First, we want to get the volume of iron piece. Okay, so the volume of iron piece equal the volume of water and the piece of iron minus the volume of water to get the volume of iron piece. So it's 80 minus 60 equal 20 cubic centimeter. And the density of iron equal the mass of iron over the volume of iron is 176 over 20 equal 8.8 gram per cubic centimeter. What about the relation between floating and sinking of matter in water and density? Okay, we will make an activity about the steps. Put the following substance in a basin containing water: a piece of wood, a piece of ice cube, a piece of cork, an iron nail, drops of oil food, a metallic coin. What about the observation? The iron nails and the metallic coins sink in water as you see in this picture. And what about the piece of wood, apple, piece of plastic, rubber pole? All of them float on the water surface. So, what about the conclusion? The materials which have higher density than water sink in it, such as an iron nail and metallic coin and scissors and fork. Okay, and what about the materials which have lower density than water float in its surface, such as wood, cork, ice, and drops of oil, plastic, apple, and rubber pool? All of them will float. Okay, and now we are going to talk about the life application of density. First, water is not used to put out the petrol fires. Give reason: because the density of petrol is less than of water, or because the density of petrol is less than the water, so the petrol floats on the water surface and water doesn't put out the petrol fires. Number two, balloons filled with hydrogen or helium rise up in the air, carrying the flags during festivals. Give reason: because the density of hydrogen and helium are less than the density of air. Number three, the change in the density of matter is used to check the purity of matter as a determination of the quality of milk. And now it's your turn, dear friend. What is the meaning of matter? And what are the properties of matter? And you have 10 seconds to answer the questions. Brilliant. Thank you so much. And now we are going to talk about the property number 3, melting point. Melting point. Matter exists in 3 states, which are solid, liquid, gas. The change of matter from solid state to liquid state by the heating is known as melting, and the temperature at which the matter begins to melt is called the melting point. So there is a differentiation, or there is difference between melting and melting point. Don't forget that. About melting point, it is the temperature at which matter begins to change from a solid state to liquid state. And about the melting, the change of matter from solid state into liquid state by heating. Okay, so don't forget that there is a difference between the definitions of melting point and melting. Okay, if you see, it is a temperature. So now I'm asking you about the melting point, and if you see the change of matter from solid to liquid by heating, so I'm asking you about the melting process. Okay, and what is meant by the melting point of ice equal 0 Celsius degree? This means that the ice begins to change into water at 0 Celsius degree. So each substance has a definite melting point, which is used to differentiate between different substances. So substances can be classified according to melting point into: number one, substances have low melting points, and substances have high melting points, such as here wax, butter, and ice. And about high melting points, such as iron, copper, aluminum, and table salt. Don't forget that. Okay? About low melting point, wax, butter, and ice. Wax, butter, and ice. And about the substance have high melting point, iron, copper, aluminum, and table salt. So each substance, don't forget this information, each substance has a definite melting point. So what about the life application of melting point? First, cooking pans or pots are made up of aluminum or stainless steel alloy which doesn't rust. Give reason. Due to its high melting point. Number two, workmen melt these solid materials. Give reason. To be easy for mixing and shaping to form alloys such as number one, copper gold alloy, copper gold alloy, copper gold alloy that is used in making jewels. Number two, nickel chrome alloy, nickel chrome alloy that is used to making heating coils. Okay. What about the boiling point? The change of matter from liquid state to gaseous state by heat is known as super excellent boiling. The temperature at which the matter begins to boil is called boiling point. So we will start with the definition of boiling point. It is the temperature at which matter begins to change from a liquid state to a gaseous state. And what about the boiling? Boiling means the change of matter from a liquid state into gaseous state by heating. So don't forget that there is a difference between the definitions of boiling point and boiling. What is meant by the boiling point of water equal 100 Celsius degree? This means that the water begins to change into water vapor at 100 Celsius degree. So don't forget this information, my dear student. Each substance have a definite boiling point, which is used to differentiate between different substances. So what about the life application of boiling point? The separation of components of petroleum oil by heating. Give reason due to the difference between them in their boiling point. As you see in this picture, when we boil the petroleum at 370 Celsius degree, it gives us fuel oil, and when we heat it or we when boil it at 300 Celsius degree, it gives us diesel oil, and when we boil it at 200 Celsius degree, it gives us kerosene, and we will boil it at 150 Celsius degree, it gives us gasoline or petrol. Okay. What about the hardness? Solid substances are divided according to hardness into three types. Solid substances are softened at room ordinary temperature. And number two, solid substances become soft by heating to be shaped easily. And finally, solid substances can't be softened by heating. For example, number one, rubber, and about the number two, metals, and finally, coal and sulfur. Coal and sulfur. Life application of hardness. The screwdriver are made up of steel iron. Give reason because it's very hard. Number two, the road used in building concrete houses are made up of iron and iron not copper because the hardness of iron is more than that of copper. Okay, and number five, I think it's number six, electric conduction. Substances can be classified according to the electric conduction into two categories. Number one, good conductors of electricity, and number two, bad conductors of electricity. First, good conductor of electricity. Substances allow electricity to flow through, such as about metals, iron, silver, copper, aluminum, and any metal. Okay? And about the solutions, some solutions as acidic solution and alkaline solution and some salt solution. So about solution, we have three solutions: acidic, alkaline, and finally salt solution. And what about the bad conductor of electricity? Substances don't allow electricity to flow through, such as gases, all gases. Number two, some solid substances, and I said some solid substances, such as sulfur, phosphorus, wood, and plastic. And some solutions as solution of hydrogen chloride in benzene, and finally sugary solution. So don't concentrate about the differentiation between the salt that conducts the electricity and the solution that don't conduct the electricity. What about the life application of electric conduction? Electric wires or cables are made up of aluminum or copper and covered with a plastic layer. Give reason: because both of copper and aluminum are good conductor of electricity, while plastic is a bad conductor of electricity, so it avoids us from dangers. Number two, electric screwdriver are made up of steel iron, while their handles are made up of wood or plastic. Give reason: because the steel iron is a good conductor of electricity, but the wood and plastic are bad conductor of electricity. I think it's so easy. And number seven, thermal conduction. Thermal conduction. So the substances are classified according to the thermal conduction into two groups or two categories. Number one, good conductor of heat, and number two, bad conductor of heat. First, about good conductor of heat, substances allow heat to flow through, such as iron, copper, and aluminum. And about the bad conductor of heat, substances don't allow heat to flow through, such as wood and plastic. And now we're going to talk about the life application of thermal conduction. First, cooking pans are made up of aluminum. Give reason: because aluminum is a good conductor of heat and it has a high melting point. What about the handles? Handles of cooking pans are made up of wood or plastic. Give reason: because wood and plastic are bad conductors of heat. This is about the part one, which is physical properties. What about the part two? But after this question, space and space are from bad conductors of heat, and you have 10 seconds. Brilliant. Second, chemical properties, metals and chemical activities. Metals can be classified according to their chemical activities into three groups. Number one, very active metal. Very active metal. We'll start with its definition. They are metals which react with oxygen when they are exposed to humid air, so they lose their metallic luster. Examples: sodium and potassium. What about the life application of chemical activities? Sodium and potassium are kept under the kerosene surface. Give reason: to prevent their reaction with atmospheric oxygen. Number two, less active metal. We will start with its definition as usual. They are metals which react with oxygen if they are left in air for some days, forming a layer of rust. Examples: iron, aluminum, and copper. What about the life application? First, steel bridges and the holders of light bulbs are bent from time to time. Give reason to protect them from rust and corrosion. Number two, metallic spare parts of cars are covered with grease. Give reason to protect them from rust and corrosion. Number three, aluminum caulking bands are washed with rough materials. Give reason to remove the rust layer formed on their surface. And finally, inactive metals. We'll start with its definition as usual. There are metals which find great difficulty in reacting with oxygen. Examples: silver, platinum, nickel, gold, and chromium. What about the life application? First, silver, gold, and platinum are used in making jewels. Give reason because they are chemically poor active. Number two, nickel, gold, and silver are used to cover other substances which rapidly gain rust, such as iron. Give reason to protect them from rust and corrosion. And don't forget that there's a difference between very active metal, less active metal, and inactive metal. About very active metals, they are metals which are react with oxygen when they are exposed to humid air, so they lose their metallic luster. And the less active metals, they are metals which react with oxygen if they are left in air for some days, forming a layer of rust. And about the inactive metal, they are metals which find great difficulty in reacting with oxygen. So if you see great difficulty in reacting with oxygen, so I'm asking you about inactive metal. And if you see reacts with oxygen if they are left in air for some days, so I'm asking you about the less active metal. And if you see it's react with oxygen when they are exposed to humid air, so I'm asking you about the very active metal. And thank you so much, and see you later. Goodbye.